Today we're here to talk about parallel line pattern development. We're going to start with a simple fitting just to show us some of the terminology, the techniques we use in parallel line. So we're going to lay out a piece of round pipe, and I've drawn an elevation view on the board, and what I've drawn is this piece of pipe here. So I have my elevation view, which elevation view always has height associated with it, and our plan view. So we're looking at it like this and like that, straight down on it. Okay, so that's one of the basic steps of parallel line, is to get those two views established as complete as we can. And at this point they're not completed because we don't have any element lines in them yet. So what we're going to start with is using some of our geometric construction techniques. We're going to establish our element lines on the plan and elevation view. So first off, I'm going to get my XY axis on my circle, and I'm going to divide that up using the radius. That will establish our 12 equal parts. So from each XY, I go left, right, up, down, and I get my 12 divisions in there. We also want to put some numbering into our drawing so that we can follow it through. And I'm going to start on the left-hand side. And I want to go all the way around. 12 equal divisions gives us 12 numbers altogether. Okay, so we have now our plan view, which has got not so much element lines, but it's got our divisions established now. So what I want to do from there is establish the element lines on the elevation view, and I'm going to do that by projecting the points downwards. So I'm going to project them from the plan view into the elevation view. This one is a center line, but now it's a element line. So once I've brought those down, that establishes my element line in the elevation view, which is where we need it. Okay, so I'm going to highlight where they are in our elevation view now. We get that. So the green are really what we're looking for as the element lines. Now we can also transfer our numbers down so that they're corresponding from views. So this one, we find 1 here, we follow that line down, and I'll label this 1 here. This next point is 2 here, but notice how we have this line of symmetry here. So 2 and 12 line up in a vertical sense here. So I'm going to bring this one down and I'm going to label it 2, 12. Three and 11 are also lined up vertically. So let's bring them down. And so on. 4 and 10 are lined up vertically. 5 and 9 are lined up vertically. 6 and 8 are lined up vertically, and 7 on the outside. So now we can call our elevation view complete. We have our full plan complete with labeling. In this case, we've used numbers. And we've established where our element lines would be on that plan view, projected them down into the elevation view, and labeled correspondingly. So everything is corresponding between views. Our next step, once we have everything drawn on this, is to establish our stretch out. And our stretch out really is the piece of metal that it's going to take to make the part. So this is where we actually establish our pattern. Now I'm going to project my baseline, and I'm going to run that just long for now, because we'll calculate it exactly out later. And I'm going to run a vertical while long as well. So I end up with, again, sort of an XY axis or a starting point. We refer to this corner as a datum point. And that's a common reference point. So everything is measured off that one point. So we'll measure to the right, we'll measure vertically. For the vertical, though, I don't need to measure it. I can merely project this point straight across here to establish my height. So I project that one across. For the stretch out, or the distance this way, horizontally for our part, it comes to the shape we see here. Okay, the distance it takes to go around the part. So how much does it take to go from 1 all the way around and back to 1? That's what we refer to as perimeter, or in this case a circle, it's called circumference. And our calculation for circumference is pi times diameter. That will be our stretch out. In this case, it's I'm going to mark halfway first because it's quite long. And mark halfway again. And there's my end point. So now I have my full blank size calculated out and drawn out. So I have the height of metal I need for this way and the length of it for our stretch out here. Next thing I want to do is, going back again to our geometric construction techniques, is I'm going to divide the blank size accordingly of how I've done it here. So in this one I've used 12 equal divisions. I want to make this equal to that. So I want 12 equal divisions here. I'm going to use my ruler on a diagonal, and I'm going to find there's a good one there. That's, in my case, I've marked 0 and 18 inches, and I'm going to mark every 3 inches. That will give me 6 equal divisions each side of center. So if it's too long to do a 12, which in most cases when we're in the drafting room we have a small ruler, a 12-inch ruler, so we can't really do much with it unless it's a very small part. And I've squared these all down. Now our key component for using parallel line pattern development is right in the name. We must have parallel lines. So all of these element lines that I'm drawing in need to be parallel to one another. And in something like a round piece of pipe, all of the lines, all the element lines are around the outside of the part, and they represent an edge. is what an element line does, or a bend. A lot of our edges are bends. In this case, it's a, think of a million bends all the way around it so that we don't even see the bends, but they truly are. It's bent all over the place to give it that round shape. So each of those points we could think of as bends. Okay, so now I've got my stretch out, I've got my element lines drawn out. Next thing we want to do is get some of our labeling onto our stretch out so that we can follow along with that. So let's do that. Now where we start with our labeling depends where we want our seam. So where do we want the joint to occur? In the case of a round piece of pipe or an elbow, we may start on center here, but for our purposes here, let's start at point 1. So we're going to start here on the left, and we'll travel around all the way around, ending back at this point. So right here is going to be our seam. So if we want our seam there, let's just label it as we see, 1, 2, 3, and all the way up. Now 12 equal spaces in the stretch out gives us 13 lines. And why we have 13 lines is because point 1 will join with point 1 on this end, becoming 1 point later. So because the seam has 2 ends, we need 2 points there, but those will become 1 once we put the part together. So now we have completed a full plan and elevation view, complete with all element lines and labeling. We've completed our stretch out view, our pattern view, our blank size, perimeter against height. We've created our equal divisions, and we've brought our labeling in so that it matches. So now we're going to take our element line heights or lengths from the elevation view and transfer those into the corresponding spot on our blank size. Now what we can do is look at the green line 1 here, and there's 2 options that I have. Sometimes, and in this case, I've done it in a way where I can project the lines across. So I may just take my drafting arm and I may just project this line right across and say here's point 1 here. And then I line up point 2 and I can project it all the way across. And here's point 3, I'll project it all the way across. And point 4. And so on. And project all of these points directly across to line up where I require them. And what we're doing is just following along 1, 1, or 1, 1, hit here, and it comes across to where we meet 1. And 2, or 2, whichever, hits the miter line, and it's where it hits the miter line, where the green line stops, is where we run it horizontally until we hit 2. And 3 to 3. And 4 to 4. Now the second option we have is to use our dividers, and this is more the case we would use in the shop because we necessarily wouldn't have this view directly beside our blank size. So we've gone to 7, we've gone all the way to here so far. I got to come back to 8. Now if I pick up the height of 8 with my dividers, I can just take it across and from the baseline swing a point up. And point 9. Again, pick it up with my dividers and transfer that length. And really what we're looking for in any parallel line is the height of these green lines. And how we get those, there's many different ways to find them. But what we require is the height in the green put onto the stretch out view here. So projection and dividers are our two most common. Pick up that one, 10, swipe it. $11. $12. And 1 is our height at the top here, we've established on our blank size. And there's all our points required for our pattern now. What we can do now is grab a flexible ruler and connect those points. Now this is a piece of round pipe, and being that it's circular or it's round in shape, but it's cut straight, just because it's cut straight, because it's changing at all aspects of it, so no matter where we are, it's constantly changing different height, even though it's a straight cut. Because it's got that round shape and it's constantly on a curve, the line will be curved here. Okay? So we take and we draw in a curved line that crosses all our points, like so. Now it's important, one thing we want to recognize too is we come along, we drop to the bottom, and then we go back up to the top. But at point 1, if we imagine it coming and connecting to this side of point 1, as soon as it joins on the other side of this one, over if there was something on the left here, it would be starting to go down, as we can see by this side here, it's going down. So that means we've hit the crest, we've hit the very peak of it. And if we think of it like this, and here's the peak, from this point over, it's coming down. So it would come down here. So what we don't want to see is a line that sort of comes up and it's still heading up. Okay, we don't want to end our pattern like that. We always want to recognize what's happening on the other side. And in this case, it's going to go down, so that means our line is going to come up and crest off before it ends. So at the end point here, we want to keep that in mind. So now we have our pattern. We can take that to the shop, roll it up, and have our part. But a couple of things we want to look at and talk about before we wrap this up. Now, in this case, we have some lines of symmetry here. Okay, we have 2 and 12 that lined up, and 3 and 11, and 4 and 10, and so on. So those points are really duplicates of one another. So if we took this whole bottom half of the circle off, and that would rub these ones out, we would have had the exact same pattern. What would have changed is when we got to 7, we don't have an 8 now, we would have gone to 7, and instead of coming around this way, we would have just turned around and gone back this way, because it was a mirror image. So we could have labeled this 6, 5, 4, 3, 2. Instead of coming around all the way the circle, we still are, but we're just using a half circle instead, and we would have traveled up and around that way. It still has to follow a sequence of some sort. We can't go from 7 and all of a sudden be at 1. It has to follow the number line. It just turns at 7. Okay? Another thing we want to look at is drawing these complete views out. Now we just said that we can drop off half the plan view, and we can actually move that down into the elevation view. So I'm going to remove our numbering here for a minute. Now we said the key component that we're looking for was the height of the green lines here, where the lines hit the miter line at a specific point. So what if I put a half circle here? Keep my radius and I'll divide that. Now I can project those up. Notice they hit in the same spot. One, two, 3, 4, 5, 6, 7. Same pattern in the end. So we could have saved a bit more time and moved this one down below. Now we have an elevation view with a profile view, which is a half of a plan view. Project that into our stretch out. So that's the beginning of parallel line development, pipe on a miter.